Hello friends, this video is brought to you by www.moeteaching.com.
Hundred plants each were planted in 100 schools during one Mahotsav. After 1 month, the number of plants that survived were recorded as follows. Now to present this data, we know that we will have to make a frequency distribution table. But it won't be possible to write each and every entry in the column like we did for marks in the previous example. So, we use the technique to group it. For that, we notice that the lowest number in the data is 23, while the highest entry is 98. We decide to condense our data into groups like 20 to 29, 30 to 39, and so on. Now let us construct the frequency distribution table and record number of plants in form of these groups. These groupings are called classes or class intervals. In each of these classes, the lower number or the least number is called the lower class limit and the greater number is called the upper class limit. And the size of the class interval is called class size or the class width. In this case, class size is 10. Let us now come back to our table and complete it. Let us now fill the tally marks. Our first entry is 95. That will lie in the group or the class 90 to 99. So we put a tally mark in that interval. Next is 67, which will lie between 60 and 69. Likewise, we complete the tally mark table. It is clear from the tally marks table that in 3 schools out of 100 schools, only plants between 20 to 29 survived. So, the frequency of school lying in this class interval is 3. Likewise, between 30 to 39 is 14. We complete the table and let us add these numbers. On adding, we find that the total is 100 and we were already given that there are 100 schools and data for 100 school was given to us. So that means we have included each and every entry in the tally marks. Hence, we see that presenting data in this form simplifies and condenses data and enables us to observe certain important features at a glance. This is called grouped frequency distribution table. Here we can easily infer that in schools which have more than 50% of the plants surviving are 8 plus 18 plus 10 plus 23 plus 12, and that comes out to be around 71 schools. So that means out of 100 schools, in 71 schools, more than 50% of the plants survived. How easy it has become by constructing a grouped frequency distribution table to infer the results about these 100 schools. Another important point to be noted is that the classes in the table are non-overlapping. That means we have taken 20 to 29 and then 30 to 39. It should not be 20 to 29, 29 to 39, 39 to 40. It will be wrong, as then the number 29 or 39 will overlap and lie in two consecutive classes. And also, we could have made more classes of shorter size or fewer classes of larger size. For instance, the interval could have been 22 to 26, 27 to 31, and so on. So there is no hard and fast rule about what classes we must choose. But the only thing to remember, let us now consider the following frequency distribution table. This gives the weight of 38 students of a class. Now suppose if two new students of weight 35.5 kg and 40.5 kg are admitted to the same class, then we will be in a dilemma to put them in which of the intervals. We cannot put them in 31 to 35, nor can we put them in 36 to 40, nor can we put them in 41 to 45. We notice that this problem is arising because there is a gap between the upper limit of one of the intervals and the lower limit of the consecutive class. In other words, we are not considering anybody whose weight lies between 35 to 36 or 40 to 41 or 45 to 46 and so on. To overcome this problem, we need to divide the intervals so that the upper limit of one interval and the lower limit of the consecutive interval are same. For this, we find the difference between upper limit of a class and the lower limit of the consecutive class. For instance, lower limit of the class 41 to 45 is 41 and the upper limit of the class 36 to 40 is 40. Then the difference is 41 minus 40 equal to 1. Then find half of the difference. 1 by 2, that is equal to 0.5. Now add 0.5 to each of the upper limit and subtract 0.5 from each of the lower limit. So we get first class 31 to 35 will become 31 minus 0.5 to 35 plus 0.5. That is same as 30.5 to 35.5. Similarly, 36 to 40 becomes 35.5 to 40.5. Now our same table will look like this. And now it is possible for us to include the weights of new students in this table. But here again we face another problem. 35.5 appears in class 30.5 to 35.5 and also in the class 35.5 to 40.5. Now, in which class should we include this student? If we consider this student in both the classes, then he will be counted twice. So we have to devise a method so that he is counted only once. We say that by convention we will consider the student of 30.5 kg weight in the higher class. That means we will consider him in 35.5 to 40.5 and not in 30.5 to 35.5. So that means we will add him in the higher class. Similarly, 40.5 kg appears in both the classes, but we will count him in the higher class. So he will appear in 40.5 to 45.5.